So today is the last section we're going to do in this chapter, chapter 6. It's section 6.8. It's all about analyzing graphs of polynomial functions. Now, do you guys remember graphing these before break? It took a pretty long time. We had to factor, we had to find the zeros, we had to use an XY chart, we had to do end behavior, all this. It was a very long process. Today I'm going to teach you guys kind of a shortcut way to do it. The trick is that it has to be in factored form. So if the polynomial is already factored for you, there's kind of a trick that you can use. It doesn't give you a very precise graph, like if you were trying to figure out like the fuel you would need to fly to the moon and back. I wouldn't use this sketch. It's not super reliable, but it does give you a pretty general idea of what the picture should look like. So we're going to learn that little trick today, and then we're just going to analyze some polynomials that are already graphed. Any questions before we get going? Alright, so here are the tricks for sketching. I want to underline the key word here is sketching. Again, if you are in charge of doing something very precise in an engineering job or something like that, I would not rely on this method. I would use the XY table method, but this will give you a quick idea of what the function will look like. Alright, so the first thing we want to do is locate the x-intercepts. Remember, x-intercepts are the solutions when you set it equal to 0. They're the roots, they're the zeros, we call them lots of different things. But it's where your graph's going to cross the x-axis, so we want to put all those points. Now, number 2 is really the trick. So we're going to decide what happens at those x-intercepts. What happens at those x-intercepts depends on the exponent with that factor. So if your exponent with that factor is an even exponent, the graph's going to kind of bounce off at that x-intercept. It's not going to go through the x-axis, it's going to turn around and make like a U shape. The higher the exponent, the flatter it's going to be. So if you have an exponent of 2, it's going to bounce off really quickly, but if it's an exponent of like 8, it's going to kind of flatten out by the x-intercept. That sounds kind of tricky, but once we get to looking at them, it's not too bad. If your exponent with the factor is odd, it's going to go through. And again, the higher, the flatter. So you've seen when we graph something with an x to the third, it kind of is like a squiggle. That's what we're talking about here. If it was an x to the fifth, it'd be even flatter, and so on. The next important thing in a sketch is just to get the right y-intercept. Y-intercepts are very easy. You just plug 0 in for x. And then we're going to talk about end behavior again, just like we did before break, to kind of wrap up the sides of our graph. So again, these are just the tricks to make a quick sketch. Okay, so the first thing we want to look at are the x-intercepts. You find x-intercepts by setting them each equal, to 0. So what x-intercept would you get from this factor? 1. What x-intercept would you get from this factor? -2. Good. Now, I want to get the y-intercept next, and then I just want to kind of fill in the gaps. So to get the y-intercept, you plug 0 in for x. So if you plug 0 into the first binomial, we get 0 minus 1, that's -1. What's -1 squared? +1. And then if you plug 0 in here, you'd get 0 plus 2, which is 2. And what's 2 times 1? 2. So I know I'm going to be up here somewhere on my y-axis. Now, let's talk about end behavior, and then we'll just kind of fill everything in. So Remember, for end behavior, you need to know what the lead coefficient is, and you need to know the degree. So to find the degree, you're just going to add all the exponents. So what's our degree here? 3, good. The degree is 3, and my lead coefficient is positive. So remember, we talked about something like this. When the degree is odd, it behaves like a linear graph with this type of slope. So off to the left, we should have an arrow going down. To the right, we should have an arrow going up, just like a linear graph with a positive slope. Any questions so far? We just kind of have a bunch of random points. They're the easiest points to find on the graph. Now we got to figure out, well, what goes on in the meantime. So we do that using the exponents. So let's look at each x-intercept and what exponent was with that factor. So here's an x-intercept. That came from this factor. What was the exponent with this factor? A 1. What did it say in your notes when the exponent is odd? What do? Go through that point. So I know I'm going to start down here on the bottom because of my end behavior, and I'm going to go through that point. Then I got to end up somewhere up by my y-intercept. Then I'm going to go down towards my x-intercept. This x-intercept came from this factor. What is the exponent with this factor? A 2. 2 is an even number. We said when it's an even exponent, it just bounces off. All right, so now just double check. Does it match with your exponents? Well, the factor -2 came from here. It had an odd exponent, and it's going through, so that looks good. I know it touches my y-axis at 2, so that's good. My next x-intercept came from over here. It had an even exponent, so it should bounce off, and then it matches my end behavior overall on the right side as well. So these are just tricks to get you a quick sketch. Now, could you get your graphic calculator app out and make it more precise? Yes. Could you make an XY chart to make it more precise? Yes. Could you actually, double distribute and do a bunch of fancy stuff and then graph that? Sure. This is just a very quick sketch. What are your questions? All right, let's start with my intercepts again. So what's one of my x-intercepts? 1, good. And at that point, we don't really know what it's going to do, but at that point, should it go through it, bounce off of it? What do you think? It's going to go through it because we have an exponent of 1. So if you want to make a little note off to the side, you can. Maybe I'll just say up here at the x-intercept equal to 1, we're going to go through, or something like that. If you want to do that, that's great. If not, that step can really wait to the end as well. What's my other x-intercept? -2. Good. And what is it going to do at the -2? If this was an even number, it would bounce off. It's still going to go through. It's going to look a little flatter, though. So I'm going to put at -2. If you want to make the little note, you can. I'll say go through flat. I think in your book it says go through curvier. You'll see when I fill it in what they mean by that. All right, now let's talk about end behavior and the y-intercept, and then we should be good to fill this in. What do you guys want to do first, end behavior or y-intercept? Oh, I heard both. Let's do end behavior. So what is the degree here? 4. The lead coefficient will be what? Positive or negative? Positive, yeah. There's no negatives, so we know it'll be positive. So it's going to behave, since it's even, like a parabola opening up because it's positive. So if you just want to sketch in quick little arrows, the ends will look something like this. So on both ends, I should be going up. All right, now let's plug 0 in to see what my y-intercept is, and then I can fill in everything else from there. So in that first one, you'd get 0 minus 1, that's negative 1. If you plug 0 in here, you get 0 plus 2, that's 2. And then what's 2 to the third? 8. So I should hit my y-axis at negative 8. So I'm actually like way down here, sorry. I put a 0 in here, 0 plus 2. 2 to the third is 8. And again, I apologize, my graph's a little smaller than I thought it should be, so sorry. I guess my graph's a little, yeah, you know what I mean. All right, so now we can just kind of fill it in. So I know I'm going to start somewhere like over here. Remember, this is just a sketch, not very precise. What happens at the negative 2? It goes through, but it goes through kind of flat. So like come in and then like flatten it out like that. So it's not like straight through, it's kind of curvy through. And then somehow I have to end up all the way down at the negative 8. Now, I don't really know if negative 8 is the lowest. Maybe it goes down to like negative 16 and then up to negative 8. Remember, these are just quick sketches, so we can't really say anything too precise here. But then it needs to come back up, and then what happens at the positive 1? It goes through, kind of flat, you know, like straight, since it just had an exponent of 1. It's kind of sort of linear-y. And then that matches our end behavior. So again, I don't want you to think these are super accurate. These are just sketches, but it gives you kind of the most important characteristic. It gives you your intercepts and it gives you your end behaviors. What questions do you guys have? All right, where do you guys want to start on number 3? Find the x-intercepts. What are they? Negative 3 and negative 5. Good. Both of them have the same exponent of 2, so what should happen at both of them? Yeah, it's going to bounce off. All right, I have a feeling my y-intercept's going to be a rather large number, but we can go ahead and find it. What is the y-intercept here? So when you plug 0 in, we get 3. What's 3 squared? 9. Plug 0 in the second one. Yeah, you get 5. 5 squared is 25. Is that 225, I think? Okay, so our x-intercept is going to be way up at 225. Don't even try to graph it. Just know that it's going to be way up there. All right? Now, that goes right along with our end behavior, because what's my degree here? The degree is 4. The lead coefficient is positive or negative? Do you see any negative signs out front? No, so it's going to be positive. So that means it's going to be kind of like a parabola at the ends. So I know like somewhere to the left I'll have an arrow going up and to the right I'll have an arrow going up. Now we know it's going to be way higher than our graph is showing. So by the time you're getting anywhere close to the y-axis, you should be way off the graph. Because we talked about how it has to get all the way up to 225 by the time it's over there. All right, that's really all we can do on this one. So I'm going to come in hot from the left I'm going to bounce off. I'm going to bounce off again, and I'm going to go up. Now, I can't say this enough. This is not a very accurate graph. Maybe it's in the negative at some point. Maybe in the middle it actually shoots up to 500. I don't know. I didn't plug any numbers in. This is just a very, very quick sketch. What are your questions on quick sketches? All right, so now we're supposed to analyze a graph that's already given to us, and I would like to point out a very key word here. We are estimating. Nothing we're doing today is very precise. So if you get 0.5 and your neighbor has a 0.6, it's fine. Okay? So we are looking for those four things: the real zeros, any maximums, any minimums, and then what degree we think this polynomial is. So zeros are the places that it crosses the x-axis. Anyone want to take a stab at any of those? It's not quite to the -2, so maybe we could say like -1.8. It's a little past 0, so anyone want to take a guess on that one? 0.5. Oh, you can see they're counting. This is 2, so 1 would be like right here. So I don't think it's halfway to the 1. Maybe like 0.25 or 0.2. You see the scale?
Yeah.
Okay, so probably smaller than 0.5. Say something. 0.25. Okay, I'll go with that. 0.25. And then it looks like, I don't know. Anyone have a guess? What? 1.5? Sure. I was going to say it looks kind of like it'd be the same as this one, but then when I looked, it looks a little farther apart. So, yeah, 1.5 is fine. Again, these are estimates. I'm not going to like come after you and tell you you did it all wrong or anything like that. Okay, now, the word maximum here is kind of misleading because you can see the maximum value for the graph would be way up here. A more accurate description would say local maximum. Local maximum is like anytime you have a high point. So here is a local maximum. Local maximums happen at turning points where you're like up at the top of the hill, like the crest of a hill. Does anyone want to give me an estimate for what that ordered pair is up there? And remember, they're counting by like halves. So this is 1. So is it up at the 1? So it'd be like
7.
So like -1.7? Okay. Good. Again, same thing for minimums. We know the actual minimum values would be all these down here. Here is a local minimum. It's a place where you turn around and you're kind of in a valley. So anyone want to take a stab at that ordered pair? I think it's 1 negative. Yeah, 1 -5 looks pretty accurate. All right, now let's talk about its end behavior pretty quickly. Does this have an end behavior of an even or an odd polynomial? Odd, right? They're going off in different directions. Good. What degree do you think this is? I would say degree 3. Good. Remember, every time it turns, that tells you something about the degree. So if it turns twice, I usually add 1, that's the degree. So if it just turns once, like a parabola, we know the degree is 2. If it turns twice, the degree is 3. You can see up on the board, those are all degree 4. You can see they turn 3 times. So just kind of analyze how many curves you see, think about what you know about end behavior, and then just kind of guess at the degree. You know, maybe if we looked at it, it would be a degree 5. There was something we just didn't know. But Again, these are all estimates today. What are your questions on this? All right, here's another one. I always try to figure out what the scale is on the graph. So if this is 5, 4, 3, 2. So yeah, they're just counting by ones here. So what are all of our zeros if they're counting by ones? Remember, zeros are the same thing as your x-intercepts. Where is this hitting the x-axis? -2. -1. I heard someone say 1, and I also heard someone say 2. Good. And again, that comes from here, 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 and here. All right, let's look for any maximums. So any turning points that have like a high point, like the crest of a hill. Here's one. Anyone know what that's at? 0, 4. Looks like I have some minimums down here. Now those are going to be a little less accurate. Looks like it's maybe like 1.5 in each direction. So let's say like -1.5. Any guesses? -2.2 I heard. Okay. I'll go with it. And then it looks like it's symmetric on the other side, so I'm going to say the same thing, except I'm going to change the sign on my 1.5. Now, if I'm looking at end behavior only, not even looking at the curves, you can see that it's going up in both directions, so I know my degree here has to be even. Could the degree be 2? No, there's way too many curves. Yeah, I would go with 4. We know there's 3 curves. That's a pretty good indicator that the degree is 4. Kind of like David was saying earlier too, we have 4 real solutions, so there's no way this could be less than 4. Okay. And I kind of use the word solutions wrong. I should tell you guys that. It's only really the solution when you set it equal to 0. So if I said 0 or roots, that would be a more accurate description of these 4 points. So I do apologize for my lack of proper terminology there. Any questions? All right, to start this off, I'm going to just make sure that I know what they're counting by. Looks like they're counting by ones again, so that's nice. All right, let's look for our zeros. Here's one, here's one, here's one. -3. 0. 3. Good. All right, here's a local maximum. We know that because it's a turning point. It's a high turning point. It looks like it's not quite to the -2, so maybe let's say like -1.8. And then it's a little above, well, maybe like halfway above. So I'm going to say 10.5. If you want to say something different, that's fine. Now, it looks like this might be the same, just reflected, or I guess kind of rotated, depending on how you want to think about it. We haven't talked about that stuff much, so I won't get too detailed on you. But it basically just looks like now the x value is positive, the y value is negative. So I'm just going to flip-flop them. But I'm going to use those same values. It's a pretty good chance that it's the same value, just with different signs. And then what do you guys think for degree? I would say 3 as well. Good. A good indicator that it's 3 again is because we have 3 zeros. And it's, if you saw like a weird squiggle off in the corner somewhere, I would maybe say it's a degree 5. We know though that for sure this has to be an odd number just based on end behavior. What questions do you guys have? Good. So again, today you might have slightly different answers than your neighbor. It's just kind of taking everything we've learned in this chapter and wrapping it up into these graphs and these sketches. I did change the number 33, 31, and 29 require graphing calculators, and I told you at the beginning of the year I would never require you to do something with a graphing calculator, so I cut it back to number 27. So go ahead and work on those. Again, tomorrow is an in-class homework day, so bring questions. Plan on working with a partner if you want, but you guys should have all the chapters homework done by the end of the day tomorrow. Any questions?